My guest is Phil Dunkelberger, CEO of NokNok Labs. Welcome, Phil.
It's good to be here.
So, Phil, fill us in on the identity space, which you fit into so nicely.
Well, the identity space is becoming more and more important. The old adage of the idea of who's out there on the internet and what are they doing while they're out there, and should they be in my network or not? Are they somebody that's approved or not approved? Big issues today. When the networks were much more closed, not as dispersed, devices were much different. You didn't have the issues with identity stacks that you have today from a technology standpoint. So NokNok Labs was created actually to enable strong authentication and work with the identities of people. So the idea behind NokNok Labs was building a common protocol that we hope someday will be an internet standard and be able to be used by anybody freely on the internet. So we've got about 200 people in an organization called the FIDO Alliance. It's a nonprofit organization designed to foster stronger uses of authentication. Think biometrics, think secure pins, think secure types of plugins to devices.
Who are the major players that are holding us back from doing strong authentication? Because over and over we've demonstrated that the best place you can spend your money for enhancing security is just implement strong authentication. All of the breaches usually involve lack of good control over at least the hashes behind the scenes. Why aren't we fixing this problem right now?
The problem is somewhat complicated on a number of factors. The first one that seems to always be a driver is cost. The risk people more and more are playing a big role in security and the cost trade-off.
Mm-hmm.
As you pointed out, credentials have been key to the last 9 major data breaches. The way that the malware was entered into the system was somebody stole a username and password.
Mm-hmm.
And so that credentialing of usernames and passwords is a 50-year-old construct that probably has seen its best days. Fundamentally, the cost is holding it back. I think the idea that there are some magic bullet here, that it's not a force of will issue for a lot of accounts and a lot of decision makers. And I think the thing that's going to start driving it has been far more of an ease of use. If I've got to carry something around that I've got to plug in all the time, or I've got to remember some complex set of issues and go get my phone and enter a code, all of these ideas are good ideas for a second or third factor of authentication, but the usability goes down. And the idea behind the Alliance and the FIDO protocol that we help create is an idea that you should be able to use natural types of things to be able to interact with your devices and the back-end systems that they support. Things like swiping a finger, touching a device, taking a picture of yourself, using your voice. Those are all common things that, until this point in time, have been really hard to hook up. Each one has to have its own wiring, so to speak. So if you've got 100 servers in your data center, you've got to go wire 100 different servers in a different way. It'd be like either plumbing or wiring in your house that all use different outlets for different devices. That just isn't practical. And then fundamentally, there's always been, I think, some resistance until Apple launched the Touch ID sensor from Authentic, who was originally one of the founders of the FIDO movement, which was, can we use a natural fingerprint touch that has become much more widely accepted? And I think you're going to see more and more devices implementing biometrics, everything from retina scanning, some of the science fiction stuff, to your heartbeat, all the way down to what I think are some really basic things like secure pins, which are easier to remember and a lot easier to type.
Yep. So how does what the FIDO Alliance has come up with work down in the weeds?
Fundamentally, it's a clever idea of very well-known, highly secure technology. And essentially how it works is, and I'll use PayPal and the Samsung phone as an example. The Samsung phone has been built, the S5, Galaxy S5 was the first. It's been built with a trusted execution environment in the chipset. And in that it contains a key. And the whole basis of the security is public-private key exchange and challenge response, something that's well-known, well-tested, and as we've seen in a number of places, known to be very, very secure, that even nation states have a tough time accessing data with public-private key encryption. That's the basis of it, and how it works is that you've got your device, you would hit the PayPal site with your Galaxy. The protocol itself would then query you as you're logging into PayPal. So you're going to log in with your usual username and password. It's going to query the device in the background, much like a communication protocol, and say, are you FIDO enabled? And the device answers back, well, yes, I am. Protocol then says, what do you have that is a FIDO element? Do you have a secure trusted execution environment? Do you have a TPM chip? What elements do you have that I might be able to use as another factor of authentication? Device answers back and gives it a list, essentially. By policy, your server on the back end then says, oh, I can use, in this case, the fingerprint reader. That is an acceptable way to do multi-factor authentication. It then queries you and says, would you like to enroll in a safer, better way to use PayPal? You know, pop-up screen that's common across devices, whether it's a laptop, tablet, or desktop machine, or your smartphone. And it then says you have a fingerprint reader located here. If you haven't used it, it instructs you how to log into it. If you have it, it uses your cached fingerprint. It uses the template that's already there. Now the beauty of this and the secret sauce is then after it's done essentially discovery and enrollment, the protocol then does something really cool. It provisions you automatically. It drops a private key in your device, puts a public key in your account, and the next time you go to log into PayPal, instead of seeing the usual PayPal login, it will say, you know, in the case of Samsung, swipe your finger. And what you're really doing is there's no biometric data exchange. None of the keys ever leave your device. So not only does it drive costs down of hooking up the biometrics, not only is it far better security, because now all you're doing is changing public and private keys with a challenge response. It's that architecture when we introduced it 2 years ago at RSA that has led to from 6 members of the original FIDO Alliance to close to 200 now. And many of the major players have gotten on board and said this is really a good way to go. So you've got people like Microsoft saying that they're going to FIDO enable Windows 10. You've got people down at the silicon level, which is very key because most of the security experts say it's better in hardware. So you've got Qualcomm saying they're going to build FIDO frameworks into their next generation of chips. And these are the kind of announcements that are now spurring a lot more uptake and pilots and trials of the spec that was just released at its final documents in December of 2014.
So in enterprise that's looking for a better authentication solution, how do they come to NokNok Labs and have you help them?
Fundamentally, NokNok Labs, we make client-level software, and the whole idea of the FIDO Alliance is someday that client software will be embedded or free. It will just be in the ether. What we've built is a security architecture and a server architecture that services that. In the classic client-server architecture, you always need management console, enrollment, policy management, all of those things. That's what our server does. So in the number of major banks that we're currently in concept stage, in some case trials with thousands, in some case millions of users, those devices are set up to be, by policy, work with their back-end servers. And it could be anything from a customer ID, logging into their CRM systems, to their billing systems, to doing e-commerce. So those are some of the applications in those areas. The two public instances where we're public is with PayPal and Alipay, both big payment systems, both very big scale. 150 million average users at PayPal, 600 million average users at Alipay.
Wow.
So the protocol itself is designed to be very flexible, very extensible, supports hundreds of authenticators today out of the box, and it gives choice, and in some cases it extends perimeter control back to the relying party or the enterprise itself.
So that discovery process when you're first logging into your bank account with your old Windows XP desktop will be, you know, it'll get all the way down to, do you have a cell phone we can use to send a PIN to, or will it be at that level?
Actually, we can use QR codes to authenticate you. Yeah, we can use QR codes. We added that. You can use a number of different ways to. Again, the interesting thing is with the older devices, if your system and policy supports it in the enterprise, for your users, whether they're inside or outside the firewall, you could simply give them a secure PIN to log in. And the secure PIN is going to do the key exchange on an older device. So you can even enter older frameworks. I go back to XP, a lot of the people, you know, we support a number of the biometric frameworks that Microsoft has had in place since Windows 7 and 8. And I know they're extending that in future versions. They've already announced that.
Is there any way to use the device identity that a lot of authenticators have come up with, which is just taking, you know, the serial number of the SIM card or the memory chip? Or?
You know, that was one of the first things that people have always done, and the interesting piece is now as the adversaries get smarter and smarter and the products they can use to spoof those devices become stronger and stronger. People have been looking for that really, the old play on words. When I say knock knock to you, your answer back is?
Who's there?
Exactly. And the idea was, can we do a three-way bind, not a two-way bind? We're not just looking at device. Of course, we can use device mapping, and most relying parties enterprises do that today anyway. We don't replace that. We augment that. Our signaling technology really says, you've got your servers and your services. You've got a whole series of devices, yours and other people's, that are touching your systems now. How do we know who's at the keyboard? And that's the fundamental ask of who's at the keyboard. And the idea behind FIDO, whether it's a biometric, whether it's a plug-in that you've got in your pocket, or whether it's something as simple as a secure PIN, you've now done a three-way bind where you need the individual, the device, and the back-end system to build that three-way key, or the two-way key exchange challenge response. The beauty about it is it keeps, as I said, all the credentials locally, which is fundamentally what everybody in the privacy circles have been saying for years. And it also builds a separate key for every server or service. So in the old parlance, back in the days of crypto, with our background coming out of PGP, was building key rings that you keep in your pocket, just like you do your key rings today in a physical world. So fundamentally, that key ring idea makes it really, really hard to get mass scale attacks. When it's in place, it's really hard to be phished, because at PayPal, you got a phishing email that said it was PayPal, and you went to go there, your device would say, I have no public key to talk to. Man-in-the-middle attacks become really, really hard because there's really no middle anymore.
Right.
So these were the kind of the scalable password reuse, usability issues that we were trying to resolve. And from a security standpoint, we were really trying to take kind of best of breed. And the guys who started this were all some of the best security people in the world. And they really have had a very good, what I'll call jousting sessions in the technical working group to get that specification to its 1.0 level.
So all this time we're talking about identity and authentication, but if you're doing so much key distribution, why not be encrypting channels and building a service that just uses that private key for encrypting a data store, for instance?
There are a lot of really interesting uses, Richard, of this technology. So one of the things that we've done prototyping for some very large people that are in the new Internet of Things idea, which is, can you do this machine to machine at scale?
Yeah.
And it works really well for that, because you can put control mechanisms. You can build this idea of attestation, which is part of the specification. How do I test cryptographically that I am who I say I am device-wise? These are kind of things that a lot of people have picked up on as part of the specification and said, wow, there's a lot of flexibility in this. We can do machine to machine, people to machine. We can even go to other types of things like data stores. So you can front end a lot of things with the protocol and enroll users to the different services you provide, whether they're storage services, processing services, communication services, using the FIDO protocol.
Dunk, it sounds like you're encouraging people to start with FIDO, and if you're the right fit, if NokNok Labs is the right fit, come to you. But otherwise, just make sure that you're fitting into this new FIDO infrastructure.
Yeah, I think fundamentally it's a broader belief system. When we essentially were funded as a for-profit startup, even though we're part of a non-for-profit movement to make it a standard, we knew not only would we have solutions, there would be a number of other solutions when the 1.0 spec comes out. The next generation of what's going to be announced will be FIDO certified products. So for the first time, you're going to have strong certification groups certifying that you're compliant with the spec. So that certification in FIDO next movement, I think you're going to see a number of people that offer a variety of things, even competitors to what we offer. So we knew when we got into this that if it was broadly adopted, there were going to be a lot of people that would have uptake at different sizes offerings. So yeah, we expect that to come.
Do you have the same issues that the IPsec consortium at the time had in actually getting the interoperability? Will you end up having to purchase the endpoint authenticators and the server side from the same organization because the interoperability is not there?
No, we haven't seen that. In fact, there's going to be announcements over the next, call it 90 days, where you're going to see some very large country-wide types of movements around FIDO, where you've got everybody from the silicon vendors working with handset vendors, working with carriers, working with banks, that have all said FIDO is a much stronger way for this entire ecosystem to work together. And if you looked at the number of players and the names that we've seen and are involved in this, in the working and testing, you've got people with their own client software. You've got people working with our server software. You've got people using trusted execution environments from 2 different suppliers that are members of the alliance. So from the silicon literally all the way to the application, you've got a vertical integration of a variety of people that are working so far seamlessly in the testing that they've been doing.
So if this is followed through on and we see it widely deployed, what will we complain about when it comes to usernames and passwords being used all the time?
I think that they're not going away anytime soon.
Mm-hmm.
You know, I like to say we didn't dig that hole in a couple months. We're not going to fill it in a couple months. I think FIDO will take time to get FIDO endpoints out there. If you said, what do I see have been the prohibitors? One, you needed a 1.0 spec. You needed something everybody, to your point, agreed on so they could make very interoperable things to be tested and certified. Secondly, I think you're going to see with announcements like frameworks around hardware from people like Qualcomm that own a big portion of that market, or Microsoft, Google's already a supporter. I think when you see those people and our ability that we've integrated the Apple devices, you've got a pretty broad coverage. Now it's just how many of them are going to be FIDO enabled, be tested, be certified, and get this thing rolled out. I think that's the next big step. And I think that's probably late this year, early next year. You're going to see a lot of announcements. And I think by the end of next year, you're going to see enough devices where it will become a more rational, what I consider, choice as they look at their business options for putting in strong auth.
So give me a feel for where NokNok Labs sits in your development on the for-profit side.
On the for-profit side, NokNok, we developed the original specification and the technology around it. 3 years ago, it was a really good idea that a bunch of really smart people had written on whiteboards from a lot of disparate companies throughout the industry. Most of the big players were in the room. It was, okay, can you build this and can you build it at scale? So we did that. We showed that in the implementations we've had at PayPal and Alipay. The next thing for us, challenge for us, was to get out there more widely adopted, more applications device supported. We've got 23 pilots going on right now, and they range in size from a traditional enterprise pilot of 20s to 50,000 employees and some customers to we've got one pilot that is looking at 50, 60 million users when it launches. And these are specific industry-specific verticals. So we built it at scale. We added things like QR codes. We continue to add things that are outside the spec that customers want. We took the Apple devices and made them part of the FIDO family when they published their APIs. So in our development, in the third year of our existence, I'm very pleased with the traction we've gotten. I mean, we've kind of been multiple startups. We had to be able to figure out the IP and make sure that the intellectual property was all covered and everybody agreed to it. We had to figure out and stand up the FIDO Alliance. We had to do the first invention, so to speak, and make it work at scale. And then we had to go get a bunch of our very large friends to say, hey, Ramesh Kanaswami's idea, our founder, is a really good idea and it should be an industry level standard. So we've been busy, but I think for FIDO itself, I think it's kind of crossed that critical mass. You don't see a lot of the infighting we've seen in other standards bodies. It wasn't, a couple of people jumped up and said, well, what about biometrics? Is there an issue with those? It's like, guys, this isn't just a biometric spec. It'll use any type of plug-in, use any kind of token, hard or soft. It'll use secure pins. It's beyond that now. And a lot of people miss that public key exchange as the basis of it. It's no longer just the authenticator itself. That authenticator is really used to kick off something much stronger and much more scalable. So I really feel the FIDO Alliance is well on its way from 2 years ago at RSA to where we are this year at RSA. As far as NokNok Labs goes, I'm very pleased with what we're doing because fundamentally we've kept saying to people, we're not trying to build an authentication enabling widget. It's not something you're going to throw over the transom with an APIs. We had to build something that supported hundreds of authenticators at scale and policies on the back end for everything from payment services to medical records out of the box. So we feel pretty good about the excellent work the engineering team and the staff of NokNok has done.
Great. Well, thank you, Dunk, because now I'm starting to feel a little bit more hopeful about the future of security.
I said yesterday to a group of people to that point, at least there's a light in the tunnel now at some level. Maybe it's not a train this time.
Yep. Thanks.
Thank you.